Um, okay, so hello and welcome everyone, both physically and virtually. Today's lecture is part of the talk series of AR5959D course called Made in Singapore 2, which explores Singapore's assemblages through computational design and machine learning, and teaching students to analyze, disassemble, and reconfigure architectural systems as a data-driven assemblages translated from architectural scale to human scale design. Karla Saldaña Ochoa is an assistant professor in the School of Architecture at the University of Florida and a faculty affiliate of the AI2 Center, the Center of Latin American Studies and Fiber at UF. She directs the AI in Architecture graduate certificate and leads the SHARE Lab, which explores the integration of artificial and human intelligence in architectural design and urban data analysis. Her research focuses on digital twins as intelligent environments applied from building to city scales and involves international collaborations across Europe and Latin America. An Ecuadorian architect and coder, she holds a PhD in technology and architecture from ETH Zurich, but her research developed multi-model AI approaches to improve rapid and accurate response to natural disasters. And we want to welcome you, and we have about like 30 to 45 minutes for your talk, and rest we can have a Q&A. Whatever you're ready, you can share the...
Yeah, all right, I'm gonna share my screen now. As I was chatting quickly or early, I always try to prepare something special when I get invited to give a lecture. And today I want to talk about a subject and that it has been present throughout my exploration with artificial intelligence. And it started by trying to think about how to create analogies that can help us grasp concepts that are somehow beyond our reach. And that started with this idea of how do we understand concepts? How do they become familiar? And then we can start using them in our daily lives. And I think the way that we could start thinking about new concepts is to use analogies. And I think the way that analogies are created is by experiences that we live. For example, we share same experiences that are directed by the law of physics. For example, we understand gravity, we understand magnetism, and we have also created some theorems or concepts to help us, for example, explain some of the mathematics behind Euclidean geometry. Like, for example, the parallel postulate, which assumes that if I use that parallel postulate, you can guess that I'm saying if our ideas are parallel, you can think that we are thinking alike. But I want to invite you today for this lecture to start thinking about new ways of new concepts that we can share today. So I'm going to set up the table for us today. And I would like to talk about the power of analogies. And I think analogies help us to grasp, as I said, concepts that are not they are complex and are not, let's say, easy to understand at the very beginning. So in order to start with the idea of analogies, I think they are really, there is this book, Surface and Essences from Douglas Hofstadter, that explains that without analogies, we cannot have concepts, and without concepts, there cannot be thought. And analogies allow our minds to think or to link past experiences with new ones. And I think what I would like to talk about today is the analogy that I have created to help me understand what technology is. So if we think about technology and its meaning throughout time, it has been spanning from thinking of a art, a skill, a craft, a method, or a system. And I think in order to help us understand what technology is today, I would like to play or to go throughout history and identify some key technology developments that I find that will be helpful analogies for us to look at technology today. So one of these examples of technology in the past was the gnomon. So the gnomon was a stick in the ground that the Greeks were using to tell time. So the gnomon will be able to tell which season of the year we were at the time because of the shadows that we would cast on the ground. But the interesting thing about the gnomon for this example, particularly about technology, is the example of Thales when he traveled to Greece to Egypt. He wanted to measure the height of the pyramid, an object that was far from its reach, and he used the technology that was as versatile as possible, that had another use, that which at the time was for tell time, which is the gnomon, but he used it to measure the height of the pyramid. In the way he was using it to create, to identify the shadow of the gnomon that will be correlated in proportional metrics with the shadow of the pyramid. So he will use the Pythagoras theorem to help him identify the size of this inaccessible object. So in this example with the gnomon, we're seeing that the object itself, though is artificial, right? This is for me one of the first artificial intelligence that we have because it's as versatile as to be the one that tells time and also the one that helps access the thing that is inaccessible. Another really interesting example that I wanted to bring as well to talk about technology is this idea of the quipus. Quipus is one really interesting instrument and tool that was used in for the Incas in before the Spanish conquer. They were using this set of strings that were attached to a larger string, and then each string will be knotted, and the knot will make reference to the amount of things they were counting, or to the things that they had on their archive, or to anything that they want to record. So the quipu itself was like a recording of all the elements, so it will help us keep track of elements that we have. But eventually the quipus became kind of an index for also storing knowledge. So the relationship between these two elements, which at the first sight could look not technological as we think today, but they are technology because they have been used to do two distinct things that are not contradictory but are complementary. So here I go with my analogy for today is I would like to think about artificial intelligence or technology as a tool that is to use and as an instrument that is to play. Tools which are meant to be efficient, which are meant to be fast, which are meant to solve problems, optimal, and instruments that will be about able to articulate something masterful or meaningful, similar to a pen and pencil or a violin, as much with the interaction of the one that is playing it. So if you try to make a difference between how could you interact with artificial intelligence that is a tool or as an instrument, I would like to offer you a position that says that you can distinguish them by the way that they're used. A tool like a hammer or a lever is able to address specific problems such as optimizing constraints or playing chess, but also, but at the same time, the artificial intelligence can be used as an instrument comparable to a pen, a paper, or a violin. And these instruments require skills to produce excellence or to produce creative work. And my thought here is to propose that artificial intelligence not only has to be seen as a tool to be efficient and to be optimal or to predict or analyze large data sets, but also can be used as an instrument to be used in a creative process and not in a relationship that is about control, in the sense that a lot of the narrative is going, saying that we have to control AI in a sense that we need to be able to manipulate it or create things exactly how we want them, but in a more playful way. So let's go back to the term of artificial intelligence. Artificial intelligence was firstly described by Alan Turing. So he thought about techniques or algorithms that enables machines to mimic human activities. What happened after Turing, when he defined artificial intelligence, is that industry and academia have been competing to pass something called the Turing test, which is this test that has been defined to declare whether an algorithm or technique is artificial intelligence. But throughout this competition of passing this test, we have created several different AI systems. And today, nobody can say that they have not used an AI model. Well, I will not be deterministic, but I say the majority of people, or maybe everybody who is in this call, have already been interacted with artificial intelligence. But the good thing about this is that we could, if we are able to understand its complexities, we can leverage those tools and instruments to help us work in our current practice. So the way that I see artificial intelligence and the way that it was categorized up until 1995 was that AI could be split into two areas of research. The one that was about symbolic manipulation. So they are all the models that are about defining rules or are logic-based, like, for example, decision trees. And then the other side, that was something that I call the neural simulation. So everything was about simulating the artificial neural network. And then within that area branch, there are two specific areas of research. One that is right now trying to explain how our brain works, and this is into neuroscience. Right now, nobody really knows, or there is many theories of how our brain works, which means that there is no certainty about how it works. But then the other side, which is abstracting as much as possible what these neural networks are, and then create mathematical abstractions, and this is what we have today with the artificial neural networks. And all of these algorithms are based on probabilities. As I was telling you, this was true, or this was real up until 1995. Also, what was true is that you could have these explicitly defined areas of application. So you have expert systems, which one of the examples are parametric generators. You had computer vision, which, for example, edge detection, or RGB analysis, which was based on image or visual input. You have natural language processing with example of bag of words, and the data that they process is text. And then you have robotics, for example, with this rule-based movement to interface between software and hardware. And then up until then, machine learning was just another application of artificial intelligence. An example for this time was logistic regression. But what we have today, we have something that it's been referred to this artificial general intelligence, or this idea that we have a multimodal data fusion approach where the areas of application right now have been fused. So you have algorithms that can have images, text, sound, numbers, and classes or categories as input for a prediction model. And then at the same time, you can have different outputs from the same input. And right now we are in this moment, right? We have the, let's say, accessibility of data, accessibility of models, the possibility of have this multimodal data approach. And so I want to come back to my initial proposal of this talk, which was the analogy of how we can understand artificial intelligence with the lens of tools and instruments. So let's start with how I have used artificial intelligence as a tool. So I was mentioning that there are already these models that are very efficient to recognize, for example, and classify type of objects. In this case, this is a semantic segmentation model from computer vision. But the question is, how do we architects or let's say anybody in the field of design, construction, and planning could use them in their practice? So I'm going to show you some of the examples that I did during my PhD and the ones that I'm currently doing at UF in the Share Lab. So this is an application that took the same technology, so the semantic segmentation approach. And the question that I have here was, are we able to encode the change that the built environment suffer after natural disaster? So in order to do that, I needed to collect the database of before and after natural disasters to be able to run the semantic segmentation algorithm to detect the footprint of before, the footprint of after, and then through a difference calculation, I'll be able to understand how much the built environment changed. But that was not only what I was motivated on, because I wanted to understand what is the effect that specific natural disasters, the length of the disaster, and the type of the disaster has to the amount of change it happens. So here in this application, I did not only develop the pipeline to identify change, but also I built it within a framework that can link specific, let's say, outcomes to a set of data sets that could tell us how much a built environment will change. Another application that I wanted to showcase today, this is in the same lines of computer vision, but then I'm also using expert systems and machine learning here. So the question we had here, this was a hackathon in 2019 that we won. The hackathon asked us that through a satellite image to identify specific type of trees, not only identify them, but then classify them per type. And then we solved that task, but we also embedded into a pipeline that for us made sense to talk about this particular application, because once you identify the trees, the next logical step for us at least was to be able to create routes or suggest routes for harvesting them. So we move from just identifying the type of trees to using the same satellite images to segment the roads and then develop optimization algorithms that based on the type of tree that you want to harvest and the time that you want to use to harvest the fruit that you need. For example, this was applied in the framework of food security after natural disasters, that you really have limited resources and you need to be efficient in the time that you spend harvesting them. So in this way, I will keep repeating this idea of using AI as a tool. So we needed to create something that was efficient, something that will solve a problem, and in this case was food security. Today, with the availability of data that we have, urban data, so I'm pretty sure Singapore also has a really good curated data set of geo-reference data sets of cities. The question that we had here is, a lot of this data, it's been aggregated into units for mapping, or units of data aggregation, like in the United States and in many countries is the census block code. But usually the census block code is not the best unit to make decisions regarding specific problems, like, for example, flooding in some areas. So what we develop here is a model that is able to, based on the features from specific data layers, like in the case of our study, we were looking at infrastructure, flooding maps, we were looking at price of housing, and we were looking at access to health. Based on these features and the geographic closeness of these specific areas, we will identify which is a much more suitable area for decision making regarding this problem of flooding. As I will repeat again, AI was used as a tool to help us solve this problem. But AI has been also been used as a tool to help us represent or recreate built environments. So in this case, what you're seeing on the screen are many of the methods that we use to recreate environments. Like, we can do it through semantic modeling through BIM. We can do it through procedural texturing by following specific algorithms. We can also do it by using photogrammetry or point cloud models. But very recently, one of the applications that we're exploring is this idea of using image to 3D. And one of the most state-of-the-art algorithms that are doing this task are Trellis and SAM 3D. But I'm going to show you, based on these three examples, what were the things that we thought of today to use them to help us portray AI as a tool. So the first example that I want to talk to you about is JackStream. So all the summing from representing the world to curating data sets and to predictive models, it led us to developing digital twins. And as I said, one of the main concerns here in Florida is flooding. So we understand that disasters are going to happen our infrastructure, urban infrastructure, is reaching its limits. So we wanted to create a tool that can help decision makers be able to understand the complex systems that are happening in the city and help them support their decision making to improve some of the or some to reduce the risk for some of the disasters, or in this case flooding, to happen. So this tool is targeted to that user. So we needed to create a web-based platform that could help manipulate or visualize specific data sets that the city of Jacksonville has, and then also be able to customize the way that we'll see this data. Another really important feature that we embed was an agentic AI interface, so we can use natural language to talk or to interface with the platform. Here, this part that I was showing you here, let's see. This particularly is interesting because the platform will allow you to, in real time, test whether a building, if you're planning to construct, will be flooded or not. But then also you can run some historic data about how many buildings have been affected for a particular historic disaster. So another application that I wanted to showcase today is a digital twin of a smaller scale. And the reason for reducing the scale from the city to the neighborhood is because we wanted to capture another type of data. So we've been looking at how to visualize and how to optimize and use the existing data sets, but we wanted to leverage digital twins not only to do that quantitative analysis, but to leverage the qualitative analysis or the qualitative data that we can gather for particular events like flooding. In this case, it's the perception of risk that people have when exposed to specific environments. Like in this case, what happened if in a campus there is a warning about a storm? When will you stop coming to campus? When will you feel that you're at risk? So in order to do that, and I'm showing you this again because it's relevant to use these quantitative data layers to inform which is the area to work on. And in this case, we decided to work on a particular site in the University of Florida campus. And then as I show you, this platform enables people who would like to check what type of data we are working on using natural language to interface with the platform that we created. What is important for us, and I mentioned this very briefly, is to develop pipelines that are leveraging all the existing modeling techniques. So one of the initial pipelines that we did was using photogrammetry, that through drone imagery, we wanted to create a building, but what we realized is that there is a possibility to use machine learning to generate the building through only one image. So right now we develop a pipeline that once you have an address, you can collect an image from that address. So here, for example, this is a traditional Floridian house. And then using this one image and the algorithms that we have implemented in our supercomputer, we can generate a 3D model of that house. And we also decided to think about other ways of applying these, let's say, reverse engineering thinking. So instead of generating the building from a image, we wanted to do that a building that has already a level of detail, in this case, very low, could we use the model to create a texture so the building itself is more in the same style than the city where it's going to be placed. So the idea with this twinning is that we want to be able to create any built environment for any city. But we don't want to lose track of what our initial question was, which is trying to gather or understand what is the effect, how is risk perceived in these environments. We know that there is these very well developed mathematical models. In this case, this is for flood search. But we wanted to translate that model into immersive environments because we found that even though images do a really good job at communicating some things, videos, and in this case, game engines are able to communicate much more content. So we created, we developed this model of that particular area, and then we started testing one of our hypotheses that if you are in this space, maybe your answers about some questions about risk will be better suited. So here we create an interface that will help, well, will be prompting the users with questions like, for example, which of the elements or which in parts of the building that you're seeing here you think are at risk or in danger if this storm keeps happening. So the participants could define the level of danger and they could tag the element. So for example, if there was a door that was in the first floor, they could tag that floor to say that I feel is a higher risk because I understand that if it gets flooded, water will come through. So AI as a tool, and it is a great application, but I want to move forward with AI as an instrument. And I think most of us probably have played a little bit with AI, state of the art generative algorithms. So this is like a very quick search online. Like if you just write generative algorithms or Gen AI, that's your instrument is going to have so many options and things to do. So here we are, right? We have these algorithms. And one of the things that I wanted to point out is that before we had DALI, which was one of the earliest in 2020, I was thinking about other ways that we can use generative algorithms to help us explore the design space. So this was one of the first processes that I did, which is trying to create a library of details that could be used and reused in specific projects. So the library of details that we developed, they were gathered from what I called at the time canonical architecture. So these elements will be categorized and used to be like, for example, if you want a detail for a floor, for a column, for a roof, for all of them were through unsupervised learning were organized and categorized and ready to be used for any project. This is one way to use artificial intelligence without the need to leverage a already trained or existing data set to generate a project. Another way that we use generative algorithms, and it helped us in a design process, and I'm going to show you very shortly how I used it. So we wanted to create also a generative algorithm that had natural language input to help us generate structural stable forms. Because one of the main problems that we have when we're working on a project as architects is that we will like to have some, not constraints, but at least validations of some of the decisions that we do on the form. Like, for example, in this case, I wanted to be able to describe how I want the form or the tower in this case be, and I will use natural language processing to define whether it should be long or strong or elegant to do that. And then that generated different options that through natural language, I will get a 3D option to help me move on with the process. But then when I finished that work, we decided that maybe it's worth not only doing this, regenerate from scratch every time you want to do or test a specific design problem. Why can we create a customizable model that if you want to modify a part of the model, it will be able to do it through natural language as well. So this is another application that we did that is moving from regeneration to a much more customizable approach to generation. So similarly to how I show you how I've used in specific projects AI as a tool, now I show you 3 examples very quickly, and I'm gonna get you to a interesting journey of thought that I'm currently now experiencing, and I really want to hear your feedback about it. So the first thing I'm going to do, I'm going to make you this seat because I want to show you what the brain of a diffusion model looks like. So right now we're navigating through how the model arrives to one solution, right? It's trying to navigate different concepts, and then it's trying to arrive to the image that is the fuse of both. Like, for example, if I ask about a cat and a hat, is trying to merge these two concepts together. So what I did is I had one prompt. In this case, the center image is the final output that you will get through these models. But what I wanted to do is actually kind of open the space around of how this image came to be. For me, what is really interesting is that when I saw this mapping, I saw that there were spaces or images that were generated that did not have the label of the final prompt that were for me really interesting to explore. And I did another, another prompt, and I had another call, and I started looking at all of these images as examples of what something else, something that I did not particularly ask for, but is within the space of possibilities, is is being generated to work with. So a combination to that can help us define geometry. It can also help us create space. But then I started thinking those images, right, they are really just virtual data, right? So they can be read and can be perceived, can be analyzed in so many different ways. So I'm just giving you here some examples. You can run a gradient filter, you can run an edge detection, you can run a like morphological components analysis. You can also look at them through their color layers. And so I started thinking, how can I, if I find these I find overstimulated, it feels very messy, this space. How can I really arrive to these in-between concepts that I got so fascinated for? So what I finally end up doing is that I encoded all of these images again. I use Fourier transform to help me only look at the patterns of the images. And then while I had all of these images encoded, I use an unsupervised learning algorithm to help me organize by how their patterns look like. So then I was able to just look at the specific of those spaces that had this pattern, that had this quality. And then through exploring those spaces, I was able to identify or look at, in this case, images, right? Images as world making, that then later, of course, could be part of another exploration of how much I want to encode this image to be something else, right? And then this image process, we mapped it into layers that can help us define a program, right? And then through this program making, we wanted to move and join. For example, in this case, we were defining words that we could read through this exploration. And then these words were transformed into prompts for the structural design algorithm that can help us not only have one solution, but it really gives you a family of solutions to work with. And then through these, we started like a typical design process, right? To do the form finding, identify the program, and then we went into the drawing. And today, with all the different generative algorithms, you could really arrive to a beautiful, beautiful render about something that you have initially thought of as just words within space. So with that, right, I think I want to say that a lot of this exploration that I share with you today is just an explorative approach. As I said, I think it's interesting to think about AI as an instrument because it allows explorative and playful and a very interesting way of looking at things you can produce, you can create without having to constrain about arriving to the optimal and the most precise solution. With this idea of the tool and the instrument, we developed a certificate that allows the students to embed or talk about this. So we have this radial structure. We have three main classes. The first one is called Fundamentals of Coding and Computation. And then we have two more classes, one that is called AI and Ethics. For architecture, we have another one that is machine learning for architects, and they are all organized within the idea that they will then be fed into a design studio core. And this is a certificate that you can take in either a year or in a year and a half if you're a graduate student here at UF. But I'm going to show you here just a little bit of the content that you will see or what is the explorations we're doing with, for example, Fundamentals of Coding and Computation, which is really a class that is trying to frame how to think when you are able to code, and what does computation mean when you can not only have one question but have several data to help you answer several questions. And with the certificate, I also started thinking about ways that we can implement what we learn into Design Studio. So how do we use, this is very simple three processes that we do in the design studio. So we do analysis, we design, and then we communicate. How can we think about the AI in this case as a tool or as an instrument in specific assignments or specific applications, and then how does the scale of the problem could be helpful for the specific tool that we're using. And just to emphasize that this analogy that I share with you about the idea of technology, right? It is as versatile that it could be do two things, not contradictory, not negation between them, but actually complementary, is to think about artificial intelligence as a tool or as an instrument. And with that line of thought, I've been working and chairing two conferences, one that is about artificial intelligence as a tool. So this is the conference called Resilience in the Built Environment. So it's a collaboration between University of Florida, University of Cuenca in Ecuador, and University of Stuttgart and Urban AI. And it's trying to identify not only which are the most efficient methods to solve particular problems using technology, but actually invite stakeholders from municipalities or from community members who would like to share their experiences on how to create or form or make resilient built environments. And the second conference that I chair, and it is something, and that's how I met Frederick, or we get to know, was through playing models. And this is a conference about artificial intelligence as an instrument, the applications of artificial intelligence as storytelling instruments, and how does it influence our practice as architects. So we are now in our fifth. I forgot to mention. For the Resilience in the Built Environment, the fourth season is going to happen in November this year in Jacksonville. So if you are, right now we're updating the website, but the QR code here is going to lead you to the website where all the information is going to be placed. And then this conference here, Playing Model, is also happening this year, and it's happening in LA at SciArc. It's going to be in September. So if you're interested in any of these two events, here are the QR codes so you can know a little bit more. But to kind of set up the questions that are coming up, I want to bring us to today, right? In 1970, we were able to see the Earth as this object. So we went to the moon. We had the boom of media, so we could understand the Earth as an object. With the internet and computers, I think the mentality or the worldview changed to see or think of it as a network. And I want to talk about how can we, what's our worldview for will be in 2050. And I think this is a very hard and complex and interesting question to ask us today, that we are in academia, that we're forming the next architects, that we are thinking about the influence of artificial intelligence and data-driven and digital twins in this world. And with that, I would like to offer one of my answers. I think there are many answers to these questions, and I envision and I hope, because I'm an intrinsic positive person, that we can perceive our world as these interconnected environments that are able to create these digital twins at different scales, that will be able to abstract different problems, to communicate, to visualize, to animate, to synthesize the world. But I think these digital twins or these virtual replicas could help us explore possibilities and provide us with timely information to make decisions that will help us to contribute to, for example, reducing the greenhouse gas emission, to help us fight against natural disaster, or to help improve or reduce the risk. And with that, I want to just tell that everything I presented here has been a collaboration with our team at the Share Lab. We are a small but mighty group. We're 9 people working, and we are all from different backgrounds. We have architects, landscape architects, computer scientists, computer graphics, and all is framed under the idea of AI as a tool. In our case, it's AI to empower creativity, and AI as an instrument. Sorry, AI as an instrument for empower creativity, and AI as a social good as a tool. So I've been giving you kind of an overview of where I started when I came to UF, and then I think it's really helpful for me to present also where I'm going and then also talk about it. I've worked with the big data, generative algorithms. Right now I'm doing digital twins, but I'm really, really curious, and I really want to go to the humanistic side of the technology, in the sense of how much is affecting our society, and to identify ways, workflows of pipelines to help create this feedback loop to help develop technologies that have a human-centric approach embedded in its core. So with that, I would like to thank you for your patience and for sitting through this presentation as I move forward to many ideas and concepts. All right, that's it.
Thank you, Karla. I will start off actually. It's not really a question. Maybe there could be a question, but thank you so much for the lecture. So there's an echo, but yeah, now I understand the whole picture of the whole the duality between the tools. I mean, AI as tools and AI as instruments, and also how there's so many layers that you like presented in a way that there's a humanistic side. There's also resiliency of the environment. So there's many layers that goes throughout the whole presentation and the history of how AI was used in our field. So like this is really like a great overview of how we've been using AI in our discipline. And I just wanted to ask, and then also it's very nice that you have these two conferences that has these two different themes and also that is implemented into the teaching. So it's quite nice to see it overall together. And I was wondering like if there's a moment where the tools and instruments come together, or are they like always parallel to each other? Like what are your, can they be one another to each other? I just wanted to see if there's or like a convergence in those two aspects.
So I think currently I think that let's say this. I find that artificial neural networks are kind of versatile enough to be a tool and an instrument. I think it doesn't necessarily need to be both at the same time. I think it's relevant to have them separate, or think of it like when it's an instrument, and therefore you can have a particular reaction, relation, interfacing with it, and as a tool. I don't think, I mean, I don't find them to be opposite. I find them to be complementary, which means that sometimes it's a tool, sometimes it's an instrument. It really depends on what are you wanting to do. And I think the idea of starting with the gnomon and the quipus is to say they were used heavily, for example, the gnomon to tell time and the quipus to count things, but they were also very helpful to do other things that were not particularly designed for, or at least conceived to do. And I think that is, for me, really interesting, because our profession allows us to not use it only as a tool, but if you talk to lawyers, to the health sciences, they will all want to use it as a tool. They will all want to have an optimal result. They will all have so many questions that are needed to be optimized for a particular constraint. So I think it is unfair to say that we can play that game of having it as a tool, as an instrument, but I really find that exercise of questioning whether you need, first, whether you need AI, second, whether it's a tool or as an instrument, and if it is either of them, maybe you have a framework of thought to approach each of them with a particular kind of intention.
Thank you. And also, I guess also that brings up different audiences from each discipline. I mean, each tools and instrument which again ties the whole discipline designers and practitioners, policymakers. So that's thank you for that answer. And I'm just gonna open up the floor to the audience and also virtual audience for questions, comments.
Hi. Thank you for the lecture. It was very useful. And I would like to ask, when your AI model is undesirable results or just wrong or anything like that, do you have a pipeline for managing the
I had some trouble understanding the question. There is echo.
Oh, yeah, maybe. Is
If
it
you
better
come
like this?
closer, yeah, that's
So
better. Thank you.
yeah, so if say your AI model is giving like undesirable results, like just wrong result, then do you have a pipeline or like a system to manage that?
Yeah, I mean, it really depends what model you're using, right? If this is a model that was trained to identify or classify data, if you already know that the model is not performing as it should because you have some validation methods, like for example, you can do an F1 score to identify what's the accuracy and precision of the model. If the model is not really giving you good examples, that means that probably you have to retrain the model to give you better examples. If the model is an image generative model, right, I think what is relevant to understand is what is the data that was used to train this model. Because I mean, not entirely, right? Because these models have millions of images I have looked at, but usually they have some feature engineering that they bias the models to have a particular look or a particular feeling. I think if you have played enough with these models, you may be able to kind of guess what's the typical outcome of those models. So if you are having something in mind that does not necessarily match with what the model is outputting, I will say you probably will be better at drawing it yourself. I think that is one of the probably not a good answer, but I will say if the model is not giving you exactly what you want, then probably you can use kind of a collage strategy that is saying, give me 20, and from this 20, I'll make one. And then I'll be intentional enough to use this part here, that part there, and I'll create something that is something that I'm looking for. If that's still not the case, then I'll say probably what you're looking for is something that you are the only one who can make it, draw it, model, whatever thing you want to do.
Yeah. Thank you.
If I feel like this is an echo,
Yeah, you have to come closer.
okay. Is this fine?
Yeah.
Okay. So hello, my name is Shiwen. I would like to ask a bit about the multimodal climate resilience research you did. That was mentioned in the slide just now, right? Um, yeah, I just want to hear more about it because I'm also I think trying to work on a multimodal AI generation project, but like combining the data from like different modes just seems really complex, like from starting out from like one source. So I don't know what's like the workflow behind it, and then like how how does it go into like that climate resilience prediction and assistance? Yeah, just like to hear more about that process.
Yeah. Well, multimodal data sets are not rare and probably are more common than the ones that are structured or curated or pre-processed. So the way that I work with multimodal data is first, you will need to run some pre-processing of each of the modes. Like, for example, if you have images, you will need to identify what is that you're looking for on the images. Are the images about, in the case of the natural disaster or the disaster response work, I was looking at the images to help me, one, get a sense of the urban or natural structure. So I will use a image processing that will help me recognize those patterns. The other way that I will pre-process my data, my image data will be to, in the case of the change detection, recognize the footprint and then the change. So the image itself is not fed directly to the model, but I will always have to run a pre-processing to be able to extract specific information per data point that I have, right? That's the case of the images. In the case of category data, like for example, I had one one feature that was about the temperature that the oceans or any water body around the disaster, the selected site where the disaster happened. I will need to transform all of these temperatures into a normalized value that I can use to fuse with the image output. And then it really, I mean, one of what I want to say, what I'm describing to you is something called federated data. What it means about is that you're able to define what are the meaningful processing that you have to do per data modality. And then the idea of federated data is that you are always repeating the same process when there's new data coming. So you don't store the real time, the real data, you just store the processing part, and which is smaller, and then you need to find and define a specific normalization method that allows you to then fuse all of the different features and create one long feature vector per, in this case, disasters. Like in my case, I wasn't trying to predict when a disaster happened. I was trying to identify similar examples of good practices based on the data set that I had. So that's what I was doing in that case of this multimodal data fusion. But there are other examples that are using, for example, social media data, which is also multimodal. You have images and text, and then you will do processing on the images and processing on the text. And then what you want to predict is, are the people posting really in danger, for example? And then this is, I mean, many examples like that. So if you're trying to do work about disaster response or resilience building, it really depends on what exactly the question is.
Oh, but no, that's still like, yeah, very nice to hear like the workflow broken down into like such the detailed steps. So yeah, okay, thank you for that.
Okay, my pleasure.
We have one last question.
Oh, hi. Thanks for your
Good.
Oh, maybe your question. Thank you. Thank you for the wonderful presentation. And I have a question about the test labeling methodology you mentioned in your previous research. It's about, I think you mentioned that using Kelsey engineering adjectives like heavy light and also the elephant, not elephant for labeling. And I'm curious about this, that when you encountered something like the different participants for the some same 3D parts, how did you determine their host for accepting or rejecting a label? Their host.
Yeah. So human perception is really tricky because we perceive right, the way that I use language may be different than the way that you use language, but there are some methods in the human in human studies that, for example, when you are trying to define beauty or something that this usually is used in object design. So there is, for example, the Kansei adjectives, which are quite established to help you define when you're talking about the form, when you're talking about the function, when you're talking about specific things of the element itself. So these Kansei adjectives helped us to have a structure that, for example, if we're going to talk about the form, we will suggest words in saying, if you want to say this is beautiful, this is long, this is large, this is slim, this is elegant, when you will input the label, this will go into try to find similar words within the Kansei adjective. So then that's how we will pair what you're describing with the adjectives that we have already pre-processed. But in order to reject or approve a label, you will need to have at least 3 people labeling the structure to be that thing. I mean, if it has only one, it will be discarded. It needs to have at least 3 coinciding descriptions of the same thing.
Oh, thank you. Hello, one last question from me. My name is Zahra. Two? Okay. Yeah, okay. So I have a question. Thank you for the presentation. I think the idea of explaining AI as a tool and as an instrument is very interesting. And you mentioned that these two paradigms of thinking about AI are actually like complementary. So I want to know, like, based on your experience, because you have experience building the models for these two perspectives, right? As a tool and as an instrument, what are the key differences in the pipeline when you are building this model? And what are the things to pay attention for? And then if we are to combine these two paradigms within like one model, what are the things that we need to look for? Yeah, I think that's my
Yeah, wow, very good question. Very complex. So I think that the architecture for using it as a tool or as an instrument doesn't change too much. I find that the tool approach will have a much more strict boundary of what things are optimal or not optimal, right? You will be able to we were talking about discarding or approving, you will be able to discard many that are not within what is your kind of range of acceptance. You can be very clear about that. I think when you're using it as an instrument, it is not about defining one solution, but it's about opening the possibility to things that are within a range of options. So it's a more explorative. So if you want to like try to attach like verbs to what a tool and an instrument is, I think a tool is like optimization and an instrument is exploration. So there are processes where you can use both tools in a design process. Like for example, when I was showing you the example of the tower, I have a similar article that we wrote about designing the roof of a stadium. We were very certain that we didn't want, for example, some elements to be without outside of the boundary of the stadium. So we use optimization algorithms to just discard the ones that are not within our threshold. And then we use the explorative AI model as an instrument to help us see what are the options that we could choose from. So I think that is more or less the pipeline, is to identify what is the task that you're doing or trying to do, and then and then try to, like, the idea I find that in a design process, you have different steps. And if you're able to implement AI as a tool or as an instrument within those steps, it really depends on what you're looking for. So I don't think it's one better than the other. I just think that they are different and they should be used in different ways.
Okay, thank you. Hello, thank you for presentation. I have a question. So digital twins kind of rely on this incomplete data. So I wonder, what's the strategy, or how do you handle data gaps, or how do you prevent algorithmic bias from reinforcing existing urban inequalities? Thank you.
Oh, very good questions and very hard. So, for example, one of the articles that I show is trying to do this data harmonization, which means that first of all, we define what are the features we want to include in our model. And the model can't be complete because when you're trying to gather many data sets, it is either let's say cohesive. So it's either trying to tell a process in defined terms, which is what we did with defining the layers, and then also curating the layers, and then it cannot be representing the whole picture. I think that's one of the problems with the models, that people think that they can be generalizable when they can't. So in order to prevent the data sets won't be they can't be complete. So what we did is we use existing methods for it's called defining proxies. So we were able to use like methods to complete some of the missing values. We were cleaning the data to be able to represent it as close as possible to the phenomena that we're trying to describe with the data. Very short answer to your question is you need to work on the data set that you're going to be using for training this model. So you cannot rely that the data is going to be complete. It will never be complete, but you just need to be aware of what is the things lacking. So you make that straightforward when you're running the model and showing the results. So in digital twins, the idea is to be able to create models based on historic data, but also understanding what are the limits of these models. If you have new data sets, they should have the same format than the historic data so you can help make decisions because you've learned something from data that you had before. It's too late for me. I hope I answered your question.
What time is it there?
I mean, it's 10:30, but
Okay.
it's okay.
All right. Thanks. Karla, thank you so much for giving us a talk. Well, we had a lot of questions, and also hopefully next time you can visit us physically. And thank you again.
Of course, my pleasure. Thank you for the questions. They were all very good. Now I have to write them down.
We have the recording, so we can share the recording. So we have all this in data. Okay,
Good.
thank you. Bye.